Bonjour, je m'appelle Tropical Trou et aujourd'hui je vais, I don't know what to try as, solve son integral. Anyways, okay, so it's Tropical Troop. This is day 6 of trying to solve the 100 integrals from 101 integrals from Black Pen Red Pen's video. We've been solving a few every day. There was day 4, we didn't solve any. We've been skipping problems here and there. I think we've skipped like 10, I don't know. But we're on number 28 now, and that's all that matters. So, yeah, we're skipping number 28. I have no idea what's going on there. We're just gonna move on to 29. Number 29. E to the 2x cosine x dx. Now, how would we go about solving this? Well, this is also equal to e to the x squared cosine x dx. Okay? Now, if we... If we try to integrate by parts, could we? I know this is equal to 2e to the 2x, the derivative of this. Oh, I have an idea. So, we integrate this by parts. U equals e to the 2x, du equals 2e to the 2x, and then dv equals cosine x dx, v equals sine x plus c. We get e2x sine x minus the integral of 2 times e to the 2x sine x. Right? Now what we do is we go again. So y equals e to the 2x dy equals 2e to the 2x z dz equals equals sine x dx, z equals negative cosine x, right? So this becomes e to the 2x sine x minus 2 times e to the 2x negative e to the 2x cosine x minus the integral of 2e to the 2x cosine x dx, and this would become a plus. So now we get, when we distribute this, e to the 2x sine x plus 2e to the 2x cosine x minus 4 e2x cosine x dx. Remember, this is equal to the integral of e to the 2x cosine x dx. What we do is we add plus, let me do this in a different color, plus 4 e2x cosine x dx and plus 4 e2x cosine x dx, which means we get phi times right? And that means e to the 2x times cosine x dx equals e to the 2x sine x plus 2e2x cosine x over phi plus c. Isn't this beautiful? Hi Barrett, you missed yesterday's stream. And the day before, I think. I don't know. But welcome back. We have solved a problem. Let's go. Yeah, it's fine. It's not that deep. Glad that you're back, though. Okay, next one. Number 30. Oh, fun. Okay, well, I'm thinking we can just use substitute, right? We make u equal x minus 3, du equals dx. We get a fun 3 to 5 u to the 9 du. Then u equals phi minus 3, u equals 2, u equals 3 minus 3, u equals 0. That means our new limits of integration would become the integral from 0 to 2 of u to the 9 du. That becomes 1/10 u to the 10 from 0 to 2. Yes, sir. 1/10 2 to the power of 10 minus 1/10 0 to the power of 10. Is this correct? What's 2 to the power of 10? Okay. I know 2 to the power of 4 is 16. So 2 to the power of 8, 256 times 2, 512 times 2, 1028. Okay, great. So 1028 over 10. Let's check that in our favorite calculator. Yeah, that's what I'm saying. 3 to 5 of x minus 3 to the 9th dx. 102.4. Okay, oh, okay, so we got the correct answer, but we, 512 times 2 does not equal 1028. So this is supposed to be 1024. Sorry, I was thinking of 2048. Okay. We have solved 2 problems now. Okay. Next one. Oh. Okay. How does one even go about solving this, like, genuinely? Are you looking at this, bruh? Oops. Wait, I have no idea what you're saying. No thanks, too. So... Okay. What if u were to equal x minus x to the 3 over 2? Du equals 1 minus 3 over 2 x to the 1/2 dx. Problem is there is no 1 minus 3 over 2 x to the 1/2 in this equation. I mean, what we could do is make this square root of x plus x to the 3 over 2 over x squared minus x to the 3rd, right? Yeah, okay. So this is what we get. And I don't even know if that made anything better. See, the main problem with what we're doing here is that three of x, wait. This could become square root of x to the 1/2 squared minus x to the 3/4 squared. It's equal to that. Problem is there's an x in both. If only we could take like an x out of the thing there. Yo, Barrett, you got any ideas? Nope. I could multiply both things by x squared, right? So that becomes x squared over x squared minus x to the 5 over 2. Now what this does, I have no idea. Wait, if I brought an x squared in to a square root, x squared equals square root of x to the 4th. Ah, so this actually becomes... Wait, okay. I want to go back to this for a second. We have the square root of x in there. Now, we know that this can become 1 over square root of x times the square root of 1 minus root x. If u were to equal root x, that means du would equal 1 over 2 root x dx, right? Therefore, this becomes 2 du equals 1 over root x dx. This root x is this, which means this can become 1 over square root of 1 minus u du. Oh my god. Look at that. Yeah, it's okay. Wait, tell me that wasn't the greatest math thing you've seen today. Like, now g, we'll just call it v. V equals 1 minus u. That means dv equals negative 1 du. That means we get negative 2 square root of v dv. That becomes negative 2 square root of v to the negative 1/2 dv. Now, how do I take the integral of this? Negative 2 times 2 to the v 1/2? Yeah, plus c. That becomes negative 4 v to the 1/2 plus c. That becomes negative 4 square root of 1 minus u. That becomes negative 4 square root of 1 minus square root of x plus c. Right, time to check this. So no steps are even supported for this. Okay. I did it correctly. Great. That was a mentally challenging problem. I am happy I've solved it. I am a better man for it. Okay, on to the next question. Oh. Oh. I've seen this before. I just never looked at the solution for it. Great. What could one do in this situation? You can take out the x, make it 1 over square root of x times 1 minus x dx. Which means you get 1 over square root of x times square root of 1 minus x dx. Now you make u equal 1 minus x. Therefore du equals negative dx. And x equals 1 minus u. And then you're left with negative integral of 1 over square root of 1 minus u times square root of u, which leads you back to square 1. Or we can make it 1 over x square root of 1 over x minus 1 dx. And since 1 over x is equal to 1 over root x times 1 over root x, we could make it 1 over x square root of 1 over root x squared minus 1 squared dx. See, once again we run into the annoying problem of the formula not allowing us to do this. Because then this would just become the secant inverse, right? This can also be 1 over x squared times 1 minus x dx. How did I get two different? Because I took a root x, I took an x back in there. And when you take an x back in there, it becomes a root x. We're gonna move on to number 33. Q33. E to the 2 ln x dx. I am sure that you can take the ln x, that these cancel out. Do these cancel out? I don't know. I don't know. That's like, I won't be able to solve this unless I know that. Do those cancel out? To just become x squared. Does this equal x squared? Okay. I think it equals that, which would make life very easy, because then we would just get our final answer to be 1/3 x cubed plus c. Let us check the calculator. I'm correct. Okay. Next question. Now, what could one do with these? I have no idea. I'm thinking if u were to equal x, that does nothing at all. That means du, right? Except we have a square root of x here. Hey Barrett, you got any idea how to solve number 34? Because I have zero clue. Barrett, friend. It's okay. It's late for you. Okay. I am a confusion man. I have no idea what is happening. What the heck? Okay, so we are 32 minutes in. We have solved uno, dos, tres, cuatro. We have solved 4 problems, and I'm very tired. So we will be ending the stream here today. Thank you to my one supportive viewer, Barrett Dudley. He's the GOAT. And I will meet everyone tomorrow. Thank you.